Okay, now let's talk about another component of big data analytics, and that's data mining. Okay, now data mining is some sort of a misnomer. So it's not about mining data or other. Data is not what you get after mining, but data is used for mining, right? And what you get is insights or information after the mining is done. Okay. So as part of data mining, what people typically try to do is to mine for patterns, mine for what is frequent, what is a frequent observation, and therefore call that as a normal behavior. Okay. So now what do I mean by all this, right? So we'll look at an example, and the most common example in data mining world is this market basket example. Okay. So in a supermarket, people buy various kinds of things. So you pick up something from a particular part of the supermarket, especially Walmart supermarkets are pretty large in size. So essentially, going into the supermarket, getting the things that you want and coming out, if you exactly knew where the things are kept, would at least take you, at least half an hour to 1 hour, for a weekend grocery shopping. Okay. How can we optimize this time? Is there a way to make it faster? Okay. So essentially, one can make it faster if by a very simple observation, and the observation is that if bread and butter are bought together, can I try to keep them together? Okay. So if many people buy bread and butter at the same time, in many transactions I observe that, hey, people buy bread as well as they buy butter. Can I keep them together? Okay. That basically helps me design a layout of the entire supermarket such that it is optimized for for helping customers do things fast. Okay. In fact, if I look at this transactional data, as it is called, so transactional data is basically data about each transaction that happens in a supermarket. So it basically is customer ID. In fact, if you have a loyalty program, then you know a little bit about this customer anyway. Okay, but a customer ID anyway, right? So and then what are the products that he bought? Okay, in this particular transaction, what is the rate for each of those products, and so on. Okay. Now using this transactional data, which is by the way in millions of such transactions happen at Walmart every day. Okay. So by looking at this transactional data and doing some pattern analysis, I can try to get answers to these questions. Where should detergents be placed in the store to maximize their sales? Okay. Or are window cleaning products purchased when detergents and orange juice are bought together? Okay. Or is soda typically purchased with bananas? Does the brand of soda make a difference? Right? Are diapers and beer purchased together? Right? The interesting aspect of all of these is that patterns in these things being co-bought can be nicely tied with different stages in a person's life. So if this guy has just had a baby, they want to buy diapers, but hey, they also buy beer. Okay? So essentially, beer and diapers then become a very co-occurring theme in this person's buying history, right? So the interesting part is, by looking at these patterns of buying behavior, one can infer significant number of things from these transactions. Okay, and these transactions and these patterns can be very helpful across. Okay. So what this chart basically shows, or this graph basically shows, is things that are co-bought together significantly. In fact, the arrows actually show, actually indicate that rice is bought by a large number of people who have also bought whole milk. Okay. So, and these rules are actually called as association rules. So by the name itself, it is sort of clear that once you have mined frequent patterns, what things people buy together frequently, you want to come up with interesting rules that maybe 80% of the people who buy whole milk also buy rice. Okay, so something of that sort. Okay, and the bigger the circle, the stronger the rule. So essentially, so for example, maybe 90% of the people who buy other vegetables also buy onions. Okay, no brainer rule. I mean, this is not a big rule. It's not a very important and interesting rule. But overall, there could be some very interesting insights that one could never think of, without looking at this data. Now, this is what is called as frequent item set mining. Okay, a part of data mining. Okay, but nobody stops you from mining sequences, other sequences, right? So, for example, can you look at human genome data, right? Data of all those people who have suffered from a type of cancer, and then figure out that sequence of genes, which is very, very frequent in these guys, right? And that tells you that, hey, this particular gene is the one which is responsible for this type of cancer. Okay. Similarly, can you look at many graphs and try to figure out some subnetworks which are very popular, and these subnetworks could be probably terrorist subnetworks or could be in networks, subnetworks of specific importance, right? Those which really occur significantly all across the graph. Okay. So essentially data mining is about mining patterns of different kinds in different kinds of data sets, right? The item set or the transactional data is the most popular one, but there are of course many others, right? Okay. So once you've mined patterns are things which are normal. Okay. You can use those patterns to define what is abnormal. Okay. So, and that is what is called as outlier detection, which is yet another important field in data mining. Okay. So outlier detection is it's also called as anomaly detection in many books and otherwise, right? So and what you want to do is to figure out a particular unit in the entire data which is behaving in an abnormal way. So for example, typical ways of doing outlier detection is about taking a column. So for example, you have salaries of people and sorting them and then saying that extremely high or extremely low are outliers. So for example, if you are looking at salaries of 100 people and Mark Zuckerberg happens to be one of them, then clearly Mark Zuckerberg will be one of those outliers. So that's called typical outlier detection, right? So outlier detection has been traditionally studied as part of descriptive analytics, but only from a one column perspective. Okay, but now if you have a data, if you have an object which is being specified using many columns. So for example, you have age of a person, you have salary of a person, you have occupation of a person, and if Mark Zuckerberg might look like an outlier if you just look at the salary field, but hey, if you look at other fields, CEO and Facebook, then clearly it doesn't look like an outlier. It seems like, okay, this is normal, it's expected. If it's a CEO, if it's a Facebook, CEO of Facebook, then clearly it's expected. Okay. How do you do something called as multivariate outlier analysis? Given data in terms of many variables, how do you figure out what is an outlier? Right? That's basically a very important problem, and that's what is also something that is studied under data mining.